Welcome to This Explainer. Today we're diving straight into a massive, absolute game changer of a shift in cybersecurity. We're looking at the Vanguard. Specifically, we are breaking down 8 AI-powered pen testing tools that are completely reshaping offensive security as we head into 2026. Things are moving at lightning speed right now, and these open-source tools, they are right there on the bleeding edge. We're going to unpack exactly what they do, where they shine, and honestly, where they still fall a bit short.
Okay, let's dive into this roadmap. We'll start with the paradigm shift, look at attack orchestrators, flexible frameworks, and smart assistants, before wrapping up with a final verdict and what this means for future workflows. Let's get to it.
Section 1. The Pen Testing Paradigm Shift. Moving from predefined rules to dynamic AI. Now, to really understand why these new tools matter, we kind of have to look at the problem with the old ones. Traditional pen testing relies so heavily on predefined rules and repetitive scanning logic. And, while that's perfectly fine for grabbing low-hanging fruit or known vulnerabilities, it completely falls apart when you're trying to uncover complex, chained exploits. AI-driven pen testing, however, totally flips the script. These tools actually understand application behavior. They can adjust their attack strategies in real time based on the responses they get, chaining vulnerabilities together to genuinely mimic how a real human attacker works. Because, as we know, the real challenge today isn't just finding a single bug. It's connecting a series of bugs into a meaningful attack path.
Section 2. Autonomous Attack Orchestrators. These are the ambitious agents taking the wheel.
So these autonomous orchestrators are definitely the most ambitious of the bunch. They're designed to take the wheel and run complex, multi-step workflows totally on their own. First up, we've got PentestGPT. Its core capability is acting as an AI-guided attack orchestrator. But here's the cool part. It uses large language models not just to spit out commands, but to actually run a strategic reasoning engine. It plans out its attack paths just like you or I would. It's built to handle complex, capture-the-flag-style challenges, and it dynamically tracks its progress across multiple domains, whether that's web, crypto, or reverse engineering.
But hey, we have to maintain some objective realism here, right? While its strategic reasoning and modular architecture are brilliant in theory, the reality of actually using it can be a bit of a headache. The setup process is notoriously frustrating. Users are constantly reporting issues configuring the LLM providers, and frankly, the documentation really lacks the clarity you need for a smooth deployment. It's incredibly powerful, but man, it makes you work for it.
Next up, check out PentAGI. This tool takes a fascinating team-based approach. Instead of one AI doing everything, PentAGI introduces a whole team of specialized AI agents. You literally have one agent for research, another for execution, and a third handling infrastructure. They run completely independently and are safely isolated inside Docker containers. It even integrates with classic staples we all know like Nmap, Metasploit, and SQLmap. But yeah, much like PentestGPT, the installation process is super complex, and getting it properly configured for real-world targets takes some serious effort.
The third orchestrator is Deadend CLI, and this one introduces a wildly unique concept. It is a self-correcting, self-learning attack agent. If an attack fails, no big deal. It learns from it and will dynamically write custom scripts to try and bypass whatever defenses are blocking it. It also runs fully locally, which is fantastic for privacy. However, while the confidence-based decision-making is an awesome feature, testing shows it's still plagued by LLM configuration issues and occasional execution failures. It's an incredibly ambitious concept, but it's clearly still finding its footing.
Section 3. Flexible Frameworks and Validators. Anchoring AI in Reality.
Okay, so while the orchestrators we just talked about are sort of ambitious experiments, these next tools are grounded firmly in reality. These are robust frameworks built to validate exploits and serve serious security teams. Let's look at our first validator, Strix. Strix is phenomenal because its entire focus is real-world attack simulation. It's an autonomous exploit validation engine, so it doesn't just, detect a potential issue and wave a red flag. It actually executes code in live environments to confirm the vulnerability with a working generated proof-of-concept exploit. It perfectly mimics real attacker behavior, scales rapidly, and plugs right into your CI/CD pipelines.
And Strix isn't just theoretical. To put this into perspective, in real-world environments, it has successfully mapped out dozens of endpoints and confirmed critical vulnerabilities like API data leakage, and get this, even a CVSS10 blind SQL injection. Finding and validating something that critical entirely autonomously proves Strix is absolutely production-ready today.
Right alongside Strix in this category is CAI, or Cybersecurity AI. CAI is a highly customizable modular security agent framework.
What makes it stand out is that it supports over 300 different AI models. Plus, it includes both offensive and defensive tooling. And crucially, especially for enterprise use, it features built-in guardrails for safe execution, which makes it a really reliable platform for large-scale research and deployment.
And this brilliantly illustrates what CAI can do out in the wild. These are real, validated findings. Authentication bypasses via SQL injection, remote code execution risks, broken access controls. These are literal business-ending vulnerabilities that CAI actively identifies in real-world scenarios. It is just an exceptionally powerful framework.
Section 4. Smart Assistants and Integrations. Amplifying the Human Tester.
So these next tools, they aren't trying to take full autonomous control. Instead, they're designed to bridge gaps, automate the tedious stuff, and directly amplify you, the human tester. First is HexStrike AI, which basically serves as an integration layer. It acts like a bridge connecting modern large language models like your GPTs or Claudes to over 150 traditional pen testing tools. It pulls this off using the Model Context Protocol, or MCP. It functions as a real-time decision engine to automate discovery, but keep in mind it's not a standalone system. You do need external AI orchestration to run it effectively.
Then we have Nebula. Think of Nebula as your incredibly smart command line sidekick. Now, it is strictly not autonomous. Instead, as you're doing your human-driven testing, Nebula watches your terminal output, suggests the logical next steps, and, this is the best part, completely automates your documentation and note-taking. It tracks your findings in real time, keeping you incredibly organized while you stay firmly in the driver's seat.
Lastly, in this group, we have NeuroSploit. This assistant combines red team, blue team, and malware analysis agents, utilizing some seriously impressive OSINT and DNS intelligence gathering. It's built to automate tool chaining and provide structured reporting. However, and it's a big however, it suffers from significant stability issues during setup. We're talking failed initializations during testing. It has great potential for sure, but it's highly unstable at the moment.
Section 5. The final verdict. What actually works right now. All right, so when we synthesize everything and test these tools against real-world vulnerable applications, what's the actual verdict? Well, Strix and CAI are the undisputed top performers. They are production-ready today for autonomous validation and enterprise framework deployment. The ambitious orchestrators, PentestGPT, PentAGI, Deadend CLI, along with NeuroSploit, are firmly in the experimental category. Promising, sure, but plagued by complex setups and bugs. Finally, HexStrike AI and Nebula are highly effective specialized tools, perfect if you need an integration layer or a smart manual command line assistant.
Section 6. Future of Security Workflows. Amplification over replacement.
So, what does this all mean for us? What are the broader implications for cybersecurity professionals? And how does AI actually change our daily grind? The absolute most important takeaway here is that AI is not replacing the human security professional, it's amplifying them. The workflow of the near future looks like this. Autonomous agents handle the repetitive scanning and the initial grunt work. This allows tools to achieve much faster detection of complex chains directly integrated into your CI/CD pipelines. And because the AI is doing the heavy lifting of discovery, human professionals are freed up to focus entirely on high-level strategy, complex reasoning, and final validation.
We are entering an era where our security tools don't just mindlessly scan anymore. They think, they adapt, and they act. While some tools are still evolving, others are proving immense value today. So for security teams looking at 2026 and beyond, the question is no longer, should we use AI in pen testing? The only question that matters now is, how fast can we integrate it into our workflow? Thank you so much for joining me for this explainer. Keep experimenting out there, and I'll see you in the next one.